start off by introducing our session chair, Dr. Chandana Gamage. Dr. Chandana Gamage is a senior lecturer at the University of Moratuwa. He is also Chief Operating Officer of TechCert, one of the leading computer security companies, which is also associated with LK Domain Registry. And he has been doing many things, so I will not bore you by saying everything about him, but he's started off by doing a degree at the University of Moratuwa, and then he did his MSc at the Asian Institute of Technology and a PhD at Monash University in Australia. So over to you, Chandana.
Good morning, everybody. May I again welcome you to the second day of the INET Collombo conference. And for the visitors from overseas, I hope you are enjoying the warm weather and the extra packed traffic in our lovely city. We are having the session till 10:30, so each speaker is kindly requested to stick to like 20 minutes. So first of all, I had the pleasure of inviting a very good friend of mine to start off the session, Champika. He's going to talk about IPv6 and the topic is about the future of it. And just to give a 30-second intro to him, he's a former IBM man and was at AIT, but is now a training manager at AppNIC, has a vast amount of experience in telling other people how good the internet is. And so given how long he has been doing it, and still people tend to hang around him, so he must be good at it. So may I welcome Champika?
All right. Thanks, Chandana, for that introduction, so I don't have to introduce myself now. Today I'm doing some advertising for ISOC because Anne Lord has asked me to do so. And anyway, I'm doing that even if she doesn't say that. So, and by the way, just to tell that as Chandana said, I come from, basically I represent APNIC, or the Asia Pacific Network Information Center, which is the regional internet registry for the Asia Pacific. So my presentation today is going to be on IPv6, basically going ahead with IPv6. And as Chandana said, I'm not going to take too long. And in fact, during the last weekend, Saturday and Sunday, we have been doing some workshops, technical workshops. And in fact, the Saturday session was oversubscribed, so we did a session on Sunday as well. But hopefully this presentation will give some kind of introduction, kind of an overview, or some motivation for you to move ahead. All right, so, okay, just to very briefly introduce APNIC in case if anyone is new to APNIC. APNIC is, as I said, the regional internet registry for the Asia Pacific region. Now, there are 5 internet registries, or what we call RIRs, or regional internet registries in the world. So as you can see, those regions are highlighted in different colors. And if you see the blue area in the middle, that's Asia Pacific region. And there are lots of economies in this region, close to around 56 or so. And APNIC is responsible for the distribution of IP addresses and also other internet resources like AS numbers and so on to the Asia Pacific region. And when I say IP addresses, IPv4 as well as IPv6. So now I think even in some of the presenters even talking about yesterday that on the internet you are nothing but an IP address. Right? So you can see that, I mean, we usually, when we visit websites and so on, we give the name. That's for us to actually just to quickly identify or as an easy name placeholder, right? But behind that, what we have is an IP address. So I have actually taken some of the websites or domain names of some key organizations or internet-related organizations. You can see that all of them, they have their web servers or the domain names on IPv4 address, which is on the top. And then you also have another address where you can see, pretty long one, that's an IPv6 address, right? Okay, so now what's the difference between this IPv4 and IPv6? Now, probably most of you are familiar, and probably you must have configured these IPv4 addresses quite a lot. So IPv4 is a 32-bit number, right? And we can pretty much theoretically have around 4.2 billion IP addresses, 4.2 billion IP addresses. And IPv4 addresses has been, the registries and also the previous to the registries, the Internet and so on, they have been distributing IPv4 addresses for quite a long time. And so that's about IPv4, the one which is shown in the top. And then we have IPv6. Even some of you may think that IPv6 is quite new, or maybe it is developed just a few years ago, but it's not. It has been there for over a decade or so, and even the early development started around in early 90s or so. But then there has been lots of RFCs and so on, and the regional registries has been basically distributing these IPv6 addresses for quite a long time as well, right? But when you look at it, IPv6 addresses are a little bit, or in other words, complicated than the IPv4 addresses. IPv4 addresses we define by dotted decimals, as you can see, whereas the IPv6 addresses, they are represented in hexadecimal. So if you're not familiar with hexadecimals, I think it's a time that you'll have to be familiar with hexadecimal. Sometimes it's not very easy to work with hexadecimals, but once you started working on it, it's pretty easy, right? And then about the numbers. Earlier I said IPv4 could have around 4.2 billion IP addresses, whereas when it comes to IPv6, you can have a huge figure over there, which is actually, I'm not going to say that because I don't know how to say that whole figure, and that has got something around probably about 39 digits or so, 340 billion, whatever it is, right? And there are some different analogies if you read the different documentation and so on. Probably it is maybe equivalent to the amount of sand in the world, maybe, right? So that's IPv6. So this is also why, again, there are lots of things that we have to think about when we delegate these IPv6 addresses, because if we don't do it properly, there can be a lot of other issues, things like the routing table sizes can grow, and so on. So there are various other technicalities behind where you might have to actually think about proper guidelines and procedures before delegating these IPv6 addresses. Okay, moving forward. Now, if you see the IPv4 address space, I think most of you might be using this IPv4 address space pretty often. So what's the status now? Now, if you think about it, that's the figure, the first chart, what you can see, that's the total IPv4 address space. Now, out of the total IPv4 address space, there has been a lot of a large amount of v4 address space, around 91. If you see the central registry, 91. Those are represented in /8s. /8 means you're talking about 16.7 million IP addresses. So that 91 /8s were the blocks that were distributed before the establishment of regional internet registries, or the RIRs. That means kind of pre-1990s or so, right, or early 1990s or so. But of course, in fact, these figures were quite more than that, but over the last 10 or 15 years, the regional registries, the RIRs, has been working on various guidelines and policies and so on, where the registries have been able to recover certain amount of historical address space. But still, we have around quite a lot, as you can see, even more than sort of 30% or so of IPv4 address space is historical address space. But then we have the blue area, right? So that's what the RIR space, the regional registries all over the world, they have, oops. Okay, sorry about that. Okay, so So that's the blue area or the blue space that I was talking about. RIRs they have delivered around or delegated around 130 /8s. So you can see about half of the IPv4 space. And then there are, of course, things like not available. Those are things like the private addresses and so on, right? And then the bottom one, of course, shows how the different RIRs, they have delegated these IPv4 blocks and so on. I don't want to go into too much details about IPv4 because it's all now, as you can see, the IANA space, or that's where, IANA, they maintain the central pools of IP addresses. So it's all 0 now, right? So there's no more IP address space with IANA, right? Okay, so where are we now with related to IPv4? Now, there were 3 stages. Probably if you have been following some of the mailing lists of INET and so on, these things probably you must have got some idea about these different stages. Now, there are 3 stages here we talk about. The first one is the green stage, or the stage 1. That was the time that the registries they have been delegating the IPv4 addresses on a normal kind of based on general policies that have been going for some time, right? But then that stage, after that, if you see the second stage, this happened around early this year, around in February. That means IANA, they finished their address pools, which means IANA allocated the last /8 during that time. That happened around in February 2011. And after that, now, if you see the third one, IPNIC reaches final 8, so final /8. So this happened in around mid-April, so which means about 1 month ago, only about 4 to 5 weeks ago. So which means that we are now into the last stage, the stage 3, the red zone, right? So that means the registries, or in the case of IPNIC, right, in the Asia Pacific, we are distributing from the last /8. Now, there are certain policies apply. Of course, when, in this whole delegation process, there are lots of policies apply, or policies and guidelines and so on. So based on the last /8 policy, it says that any organization, they can get maximum up to a /22 of IPv4 address space. So when we say maximum of /22, if you calculate that into numbers, that's coming around 1,024 IP addresses, right? So now you have to think whether is 1,000, let's say if you are a ISP, so once you get your 1,024 addresses from the last /8, that's about it. You can't get any more v4 from that last /8. Right? So then you'll have to think whether that 1,024, I'm pretty sure that it may not be enough for you, right? So after that, what are you going to do, right? So these are the questions that you'll have to address. So what is next? So ISPs will need to address for new network infrastructures. And that means they'll have to get IPv6 addresses only. Right? They will receive only IPv6 addresses. What about the end users? They will start receiving IPv6 internet services, right? So they can still have their, whatever the v4 addresses what they have at the moment, but in the future, of course, even now, if they have got that last /22, they're going to receive IPv6 only, right? So these are the things that you will have to, or in generally as organizations, what you will have to think about. What about ISPs and operators, right? They have to pretty much, think about this quite seriously. So very soon, you